This video is going to show you how we graph three quadratic functions on the same coordinate system. And our first one in this example is y equals x squared. That's our basic quadratic function. And when you're graphing on my MATLAB, you want to use 3 points, and one of them is the vertex. Now all of these quadratic functions have a vertex at 0, 0. So what I've done is I've made a table, and I'm going to plug in the x values. For the first one, y equals x squared. When you plug in -1 and square it, you get a positive 1. So the y is equal to 1. When you plug in 0 for x, y is 0. And when you plug in 1 for x, y is 1. So that's 3 points on our parabola. So I'm going to go click on the graph and select the parabola graphing tool, the 3-point quadratic tool. That means you have to plot 3 points. So my first point I'll plot is at -1, 1. Then I'll plot the vertex at 0, 0, and the next point at 1, 1. Now I'm ready to graph the second one, which is y equals 3x squared. By plugging in -1 and squaring, I get positive 1, times 3, I get 3. Plugging in 0, I get 0. And plugging in 1 for x, I get 3. So those are the 3 points I'm going to use. Again, picking up my quadratic 3-point quadratic tool, I plot one point at -1, 3, another point at 0, 0, and another point at 1, 3. Now for my last quadratic equation, I have y equals 1/3 of x squared. So if I were to plug in 1 for x and square it, I would get 1 times 1/3, I would get 1/3. And now that's kind of hard to graph on my grid here. So I'm going to choose a point that will give me a nice whole number for the coordinates. So if I plug in -3 for x and square it, I get a positive 9. And 9 times 1/3 is 3. So I get 3. And then when I plug in 0 for x, I get 0 for y. And when I plug in a positive 3 for x and square it, I get 9 times 1/3 is 3. So those are the 3 points I'm going to use in graphing the third parabola. Now what I'll do is I'll zoom in so you can see this. I'm going to select the parabola, the quadratic. The first point, I'm going to choose -3, positive 3. And then my next point is 0, 0. And then my next point is positive 3 for the x and positive 3 for the y. And I can save that and check my answer. Okay. Moving on to part B. Let's look at that coefficient. In the first one, the coefficient is 1, the second one is 3, and the third one is 1/3. How does the coefficient a of x squared affect the shape of the graph? Well, my first graph was y equals x squared. That was the one in the middle. With a 3 out in front of the x squared, I got my second parabola, which was the narrow parabola. So that 3 resulted in a very narrow parabola. Now the 1/3 in front of the x squared resulted in a wider parabola. So out of these options, the one that makes sense here is that the greater the absolute value of a is, the narrower the parabola will be. And that smaller the absolute value of a is, the wider the parabola will be. Let's check my answer. Nice work. All right, so practice this on your own and continue working through the problems, and let me know if you have any questions.